So, chapter 5.1 is all about the study of statistics. And this first unit is about the measures of center and spread. Some of these terms you may have already worked with before, so let's get started. First off, the first one is mean. Okay, another word for mean is basically average. Okay, now with that, the average is basically the sum of all the set of data values, right, divided by the number of values you have. And if I look here, right here, this symbol here, anytime you see it, represents mean. This is basically telling you that you're dividing by the number of terms. This is representing the number of terms. And since it's in fraction form, right, it's basically telling you what you're dividing by. When you see this symbol here, this symbol means sum, right? And these numbers here, right, tell you're adding all the terms from the first term all the way to the nth term or the last term. X sub I is telling you you're adding all of the terms together. So it would be like X sub I would be the sum of X sub 1, X sub 2, X sub 3, right? All these values that we're adding represent X sub I. Okay, and we'll talk about that a little more in some examples. Okay, median is the middle value in a data set. This represents half of the values that are below the median and half that are above the median. Now, generally, we use the median when there is an outlier. And we'll talk again about that a little more later on. Now, if you have an odd number of data, right, you have one exact middle. So if I have 1, 2, 3, 4, 5, right, I have an odd number of data, and if I look right away, I have one middle term. If I have an even number of data, okay, such as 1, 2, 3, 4, 5, 6, what happens here now is if I go to find the middle, I knock one off each end. I have two middles here. So what I do is I add the middle terms and divide by 2, and that would give me the median. Okay, so you have to separate the mean and the median. An outlier, what is that? We mentioned it just above. That is a value in the data set that is much greater than or much less than all the other values in the data set. Range is the difference between the max value and the minimum value of the data set. So if I gave you, 10, 12, 16, 20, 26, when I go to find the range of this data, I take the maximum, right, 26, subtract the minimum, 10, and my range is 16. It tells you how spread out your data is. Okay? Now, standard deviation will be the most complicated part of this lesson, and that is a measure of the spread of a data set. How far away from the middle is all of the data is what they're talking about. The standard deviation summarizes the distances of all the data values from the mean, or basically the average value. Okay, so let's take a look here. So in statistics, right, the mean is the same thing as the average. Okay, to find the mean, find the sum of the data values and divide by the number of data values. So write a formula for the mean. So we're going to say the mean, and that's a symbol for it, is equal to, I'm going to add all of my data values all the way to my last value. Then I'm going to divide it by the number of terms I added together. So let's use this in an example. Now, the sigma notation is that whole x, the mean, is equal to 1 over n times the sum of I to n of x sub I, right? So this is like what they're telling you the mean formula is. Now, this is our data set here, right? You know the mean is going to equal, and actually let me make this bigger so it's easier to see, right? The mean is equal to 1 over how many terms do I have in that set of data? Well, I have 1, 2, 3, 4, 5, 6 terms. So it would be 1 to 6. Okay? Now, that means I equals 1, and up here is 6. So what this ends up being is the mean is 1/6 of the sum of 4 plus 5 plus 34 plus 34 plus 44 plus 53. Those numbers came from the data set here. Okay? So when I go ahead and I add those, I basically end up getting 1/6 times 174. I could also say that this is the same as 174 divided by 6, which is going to give me a mean of 29. So if I add those together, divide by 6, I get 29. Now, in my eyes, do you have to go through writing all of this down, then this, and then all of this? No. What I would do is just add all of the data pieces, get 174 divided by the number of pieces, and you get 29. That's a quick way to do it. So now, the median, right, is the middle value when all the data is arranged from smallest to largest. Okay? So the first thing we have to do, anytime we go to find the median, the very first thing we have to do is order the data. So what I like to do is go 11, then I look and I see 27, then I see, 33, then 46, 50, 78, and 83. And I'll always double check. I have 1, 2, 3, 4, 5, 6, 7 pieces. 1, 2, 3, 4, 5, 6, 7 pieces. Now, since I have an odd number of data, I know right away I'm going to have one exact middle. So to find the middle, I think sometimes for kids it's easier just to do, take one off each end. And when I look, I have one middle left, which is 46. Okay? Now the next set of data, I'm going to go ahead and order that. So I go 11, 27, 33, 46, 50, 78, 83, and then 90. Now when I look here, if I count the number of pieces of data, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So when I look and I take one off each end until I get to the middle, I notice right away I have two middles here. So if I have two middles, what I have to do is add those values together. and then divide by 2. So this gives me 96 divided by 2, which is 48. Okay, so the median here would be 48. When I look at this, how does an unusually large outlier affect the mean? If there's a big number within your data, it's much bigger than all the other data. What that does is it's going to raise or increase the mean. Okay? If it's a small outlier, right, what that means is it's going to lower your mean. So it's going to make your mean or average smaller. Generally, if you have an outlier, we never really want to use the mean if there is an outlier. We always would want to go to the median. So if the data contains an outlier, which measure of center should you use? And that would be the median. Okay? If your data does not contain an outlier, which measure of center should you use? And that would be your mean. Okay? And that's important to know. Okay? So the range is a measure of spread. Okay? And that equals the maximum value minus the minimum value. So when we go to look at this range of data, we're basically taking the highest piece of data, which is 97, and subtracting the lowest piece of data, which is 12, which would give me a range of 85. Okay? Now, in this example, is there an outlier? If there is, go ahead and circle it. So if I look, I'm not going to circle it, I'm going to highlight it. If I look, there's one piece of data that is way off, and that would be the number 97. And if I look at that, right, this would increase the range of the data set. Okay. Now let's talk about the standard deviation. So what they do is they give you a small set of data to help go through and learn what the standard deviation is. Okay, so here's your data. And the first thing they want to do is have you find the mean. Okay, and when you go to find the mean, all you're going to do is first add up all your data, right? And then you're going to divide by the number of pieces of data. So if I go to my calculator, I'm right away going to go 3 plus 4 plus 6 plus 9 plus 13. Hit enter, and then divide that by 5. And my mean is 7. Okay, so this gives me 35 over 5, which is 7. So now, the next part they want you to do is they want you to basically take all of these x values and subtract the mean. All right, so we would do 3 minus 7, which is negative 4. 4 minus 7, which is negative 3. Then 6 minus 7, which is negative 1. 9 minus 7, which is 2. 13 minus 7, which is 6. Now, once we get that, what we're going to do is take each of these and square it to get 16, 9, 1, 4, and then 36. So then what I'm going to do now is I'm actually going to just go ahead, add those up, and I would get 66. So basically what I did is I took these values and I added them up. Okay? Now, what we're going to do now, so now what they're going to do is have you find, right, you're going to take the sum, right, that we just got here, which is 66, and multiply it by 1 over the number of terms, right, that's n, minus 1. So s squared is equal to 1 over, how many terms did I have? 1, 2, 3, 4, 5. So 1 over 5 minus 1 times, what was my sum here? That was 66. So now that gives me 1 over 4 times 66, right? So s squared equals 66 over 4, which is 16.5. So now, once I have s squared equals 16.5, right? Now to solve that, I'm going to take the square root of both sides. So if s squared equals 16.5, square root, s is equal to the square root of 16.5, which is approximately 4.06. So your standard deviation is 4.06. Okay, now, so there's a few things that you need to know about standard deviation. All right, and let's look at them here. So, 1, the standard deviation says that the data that are spread out will have a large standard deviation. So if you have a big range, right, your standard deviation will be large. Data that are close together will have a small standard deviation. Okay? So a data set has a standard deviation of 0 if all the data values are the same. A standard deviation can never be negative because it represents distance, and most of the data, all right, in a set lie within 1 standard deviation of the mean. In other words, for most values, the distance to the mean is less than 1 standard deviation. Okay? So in this last one, if you have an outlier, right, what will that do to your standard deviation? Well, it spreads your data out more, right? And if it spreads it out more, what happens is it increases your standard deviation. Okay? So let's look at the checkup real quick. And it says use the following data to calculate the mean, median, range, and standard deviation. Okay? Now, Jamie McAllister is a wonderful rebounder for her basketball team. Of her final 10 games, here are her rebound totals for each game. Okay? So we want to collect the data. From the collected data, what is the mean or the average number of rebounds? So what we're going to do is we're going to add up all these values. So we're going to go 8 plus 12 plus 8 plus 11 plus 15 plus 6 plus 9 plus 8 plus 10 plus 13. When I hit enter, I get 100. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I divide that by the number of pieces, I get 10. So what it is the mean here is 10. Now find the median. Well, what I'm going to do is put the data in order first. So 6, then 8. I have 3 8s, right? So 1, 2, 3. Then I have 10. Then 11. Then 12. Oop, I forgot 9, sorry. 9, 10. 11, 12, and then we got 13 and 15. So when I look at this, if I cross off the data, right, I end up with two middle points here, okay? And the two middles are going to be 9 and 10. So if I add those together and divide by 2, 19 divided by 2 would be 9.5. And that would be your median. Now, the range, okay, of Jamie's rebounds, right? If I look here, what's the largest value? 15 minus the lowest value would be 6, which would give you a range of 9. And if we had to go and find the standard deviation again, right? Remember, the first thing we're going to do is take all of these x values and subtract the mean. The mean was 10, so we're going to do 6 minus 10, which is negative 4. 8 minus 10, which is negative 2. I get another negative 2, another negative 2, negative 1, 0, 1, 2, 3, and then 5. Now, what I'm going to do is take all of these values now, right? And I'm going to raise them to the second power. So that's going to give me 16, 4, 4, 4, 1, 0, 1, 4, 9, and 25. Now, when I go ahead and I add these all up, right? When I add this column up, I get 68. Now, with that, if I get 68, now I know s squared is equal to, that sum there, right? So I'm going to take 68 divided by, I had 10 pieces of data. So I'm going to do 10 minus 1 gives me 68 over 9, which gives me s squared equals 7.56. Now I'm going to take the square root of both sides, and s gives me approximately 2.75. Now, another way to do it is actually use your calculator, all right, if you have a graphing calculator. If I go to Stat, and then I'm going to go Edit, I'm going to go enter just all my data here. So I'm going to go 6, enter, 8, enter, 8, enter, 8, enter. Then we have 9, 10, what do we have, 11, 12, 13, and 15. Now, once you have all your data plugged in, if you hit Stat and you arrow over to Calc, what we're dealing with here is one variable statistics. So what I'm going to do is hit Enter. Then I'm just going to continue hitting Enter all the way till I get to this menu. And right away here, when you see this top right button, it tells you your mean is 10. And if I look here, it actually gives you your standard deviation, which is S sub x, which is 2.75. Okay, so this number here would round to 2.75. Okay, so this tells you everything you need to know, basically. Okay, now, number 5. When a smaller outlier is added to a sample, the mean gets smaller. when a small outlier is added to a sample, the range, right? What happens is it gets larger. It increases because you're putting a real small number in with higher numbers. It's going to increase that range. All right. When a smaller outlier is added to a sample, the standard deviation, right, gets larger. Okay. What is a better measure of center for these values? Why? If I look at this data, 18, 19, 20, 20, 23, 26, 260 is a pretty big outlier. And anytime I have an outlier, especially that big, I would want to use the median. Okay. Here it says, these are the mean weights and standard deviations for 2 samples of 6-month-old puppies of different breeds. Breed A, the mean weight is 42 pounds with the standard deviation of 2.4 pounds. Breed B, a mean of 30 pounds with standard deviation of 4.8. What breed has a higher average weight? Well, if I look, mean is average, so right away I know breed A has a higher average. What breed has weights that are more spread out? Remember, the data is more spread out when the standard deviation is high. So when I look, breed B has data that's more spread out. And that's just by comparing the standard deviations. So if the dog weighs 12 pounds and is added to a sample for breed A, the new standard deviation would likely be, right, greater than, okay? It would be greater than 2.4 pounds. Okay, go ahead, try the quiz, and let me know if you have any questions.